Yeah. Hello, Manjnath. I think we can start. If someone is joining in between, we can address them separately. Am I audible?
Yes, Vamshi.
Yeah. Thanks for confirming. I'm just sharing my screen.
Sure.
Right. So, hello, Manjnath. Vamshi this side. So, I'll be your instructor for this demo course. Okay. So, I'm working as some software developer in one of the US product-based company situated in Hyderabad. I'm based out of Hyderabad. Right. So before we start off, you have anything to me? Just before we entering into this demo session, do you have any questions or anything to me?
Unannounced.
Yeah, okay. So this demo session would be around, around half, 1 hour to 1 hour, 10 minutes. I'll cover up few things, what we are going to learn, what is the importance of those stuff, everything. So if you have any questions, you can unmute yourself or you can put in the chat as well, right? Or else
Yes.
if you feel we can discuss later, at the end of the session, we can have some Q&A session, right?
Sure, sure.
Yeah. So yes, this is the syllabus details, right? So I have prepared my own syllabus as well, but this is from one of our faculty. So I'll share you this at the end of the session. You can go through. So this is a Spring Boot and Microservices course. So the prerequisite of this course should be Java and some Java based configuration, some Spring Core and Spring MVC. Basically, we can say Spring framework. But if we know Spring, learning Spring Boot would be much easier. Though if we don't know Spring Boot, that is okay. Sorry, Spring, that is okay because Spring Boot covers those things as well. But if people are having prior Spring experience, Spring framework, that would be good for them, right? So let me start this. Yeah. So Spring Boot. And microservices. Right? So what exactly is Spring Boot and microservices? So Spring Boot is a Java framework, okay, built on top of Java and Spring, which adds additional capabilities, which makes us development, day-to-day development easy, by removing some boilerplate code and this thing. So if you know Spring, if you already know what is Spring, Spring is a framework built on top of Java, right? In the same way, Spring Boot is an additional framework built on top of Spring. So people who are working with Java programming language and technologies, okay, like servlets and JSP technologies initially, they found out they're writing some boilerplate code over there. To remove that, they have come up with a framework called Spring at that time. But though they come up with Spring, there are some other issues with Spring as well, right? There are some XML level configurations and still they need to deploy it to the server, the jar file or the application, right? So to address all these small, not issues, some bottlenecks, we can say some delays. So they come up with some other framework on top of Spring, that is Spring Boot. So it solves everything. So it removes XML configuration or the manual configuration. It provides a Spring Boot embedded servers, right? We don't need to go to other servers or explicit servers. Spring Boot itself will come up with the embedded server. It removes the complete XML configuration, right? Some issues, whatever we have issues or concerns in Spring Boot is addressing that. So I'll explain you what are those slowly when we are going through the course, and microservices also. So microservices, the reason for getting into this is Spring Boot or and microservices. Microservices works well with Spring Boot. Microservices, by the name itself, it is saying small services, right? So monolithic application, all our functionality would be in the same application, and microservices is completely alternate for that, the extension of it. We will break our backend system into small applications, and we'll make sure they are communicating with each other for our functionality, right? So Spring Boot and microservices. Prerequisite, as I mentioned, must and should Java, core Java. And if people are having Spring framework experience, well and good. If not having Spring experience, that is also fine, but it's good to have, because persons who are as willing to learn Spring Boot newly, they are directly jumping into Spring Boot without any Spring framework idea. I'll try to cover up that as well, right? So before deep dive, I'll just explain what exactly it is doing. Spring Boot is a Java framework which helps in application development. Without writing boilerplate code, right? When I say boilerplate code, the repetitive kind of code, always will repeat some codes. Uh, for example, in Spring JDBC, right? Or in core Java, there is a concept called Java database connectivity, right? So there we have to create the connection first, or register the driver, right? Create the connection, register the driver, and prepare a statement, execute that. So this is all repetitive steps every time. Though we will create some functions and address that issue, but again, still somewhere we need to repeat the code. We can consider that as some boilerplate code. Okay. So for example, I took that Java database connectivity, but there are many instances where we would need to write that boilerplate code, worry about the configurations, right? So Spring Boot completely removes that boilerplate code wherever it is possible. So currently we have Spring 3.x, I guess, the version, right? And in the coming versions, they will address many more issues or many more concerns. So it is basically making the development very easy. Okay, it's a framework, Java framework, which helps in application development without writing boilerplate code. Okay, so what is framework exactly? Sorry for that. So normally we have three different kinds of concepts. Okay, programming language, programming language, technology, and frameworks. So what is programming language? Programming language is a core level feature or core level language which have syntaxes to build some application. For example, C++, C, Java, and Python, JavaScript. All these are examples of programming languages, right? So programming language, nothing but, the core level, the base. Whoever has invented the programming language, will start using those variables, uh, next functions, literals, object-oriented concepts or procedure-oriented concept, right? So all these things comes under programming language, right? It has some set of rules and syntax to write software programs. Okay. It has some set of rules like, if condition should be like this, variable declaration should be like this, function declaration, function method should be like this, the body, function signature should be like this, how we need to create an object, how we need to call an object. So those all comes under programming languages and technology. So technology is something built on top of programming languages, or we can say built with programming languages. So that will create some protocol or standard. Okay. For example, we need to work with the web applications. So for web applications, the famous protocol is HTTP, right? So HTTP is a protocol, web application protocol that allows to communicate with other applications. Let's say I'm building a Java application and there is some REST API or HTTP request provided or exposed by some other service from some other area, some other place. Okay, that protocol is something that allows me to communicate with them. So from internet, we call it as web, right? So that technology, we call it as web technology, right? So technology is something where we will use core programming language inside that. Okay. And with that programming language, we will create something which will give additional advantage to us where programming language is not providing. Like this web development, web technology is a technology, cloud computing is a technology, data science is a technology, right? Web technology. So in web technology, we can say in Java, we have servlets, servlets API. In data science or data engineering, we can say Spark is a technology, right? Or framework, we can say. So Spark framework. So when it comes to frameworks, so frameworks are not mandatory. They just ease our process of development. Okay. They will use combination of programming languages plus technologies. Okay. For example, Spring Boot is a framework. Okay. So combination of programming languages and technology. When I say programming language, the CoreJava here and the technology, Servlet API together and using with some other dependencies or some other libraries, it builds a framework which gives the developer a free hand to develop systems, lightweight applications and the production ready applications very fastly. Instead of writing all the boilerplate code every time, instead of worrying about the configurations, instead of worrying about the server deployments, right? So this gives a chance for the developer to concentrate more on the business logic rather than the boilerplate, the the boilerplate code, the repetitive code, right? So we are learning framework here. Spring Boot is a Java framework which helps in application development without writing boilerplate code, right? So, and microservices is also a framework we can say, or the tech, it's a pattern we can say where we are just breaking down our larger application or monolithic application into multiple small components for our ease of development and deployment. I'll cover that once we do this introduction, this about boot and microservices. Okay. So yeah. So what is the applications of Spring Boot? So Spring Boot mainly focus on developing enterprise level applications. Hmm. Enterprise level applications. So when I say enterprise level, large enterprises like Amazon, Flipkart, I'm taking those as an example, but every system is an enterprise system. Okay, every application is an enterprise application where they'll depend on internal sub web applications. For example, I'll take one more paint here. Yeah, if you see, let's say we have Amazon.com, it's an e-commerce application, right? So internally, when we log into Amazon, we'll see multiple catalogs here, multiple catalogs. For example, we say home decors. I'm taking this as an example. Okay, home decors, some what do we say? Some furnitures, some catalogs. So once we click on the home decor, again it will open subcatalogs. Okay, so it will show everything, whatever the products we have, whoever the sellers are associated with that. So these are all catalogs and subcatalogs. So have you ever wondered how they are creating this? How they are getting all the data? Let's say I need some home decor products. Okay. And I'm looking for a product and I'm searching in Amazon. Immediately I'm getting multiple products with price, with details, specifications, delivery date, or I mean expected delivery date, payment services, everything. But have you ever wondered how they will create that data? So when they have this as a front end, as end user, we don't know any technical knowledge. I'm not from technical knowledge. Let's say I'm some 10th class or intermediate student, right? By the time I don't have any technical knowledge, I'm just an end user, a user who uses application without any technical knowledge, background technical knowledge. So I'll log in, I'll search for a product. I'd like to order it. I'll order it, but how we are getting that data? So Amazon.com is an enterprise level application. Okay, so any application would have a backend database. So since this is an Amazon catalog, I would say this is a catalog DB, catalog database where it store all the data. For example, pricing data, product data, offers data. So multiple. So let's say I have a product X, okay, and that product X is some 100 rupees. So that product details like specifications is a product data. and offers like if you buy by today 5 p.m. or 6 p.m. you will get some 10% off. So these are different levels of data, different types of data in the catalog database, pricing, product offers, other stuff. We may have multiple, a number of data. Okay, but how they are creating this? In order to create this catalog data, they will have small web applications internally. So this we are using as an end user. Okay, for example, this is internet. I'm an end user here. I'm accessing the Amazon web application through my internet in the browser, and it is giving me the response. I know only this thing. So backend we have catalog database, but internally what's happening we don't know. This is the client-facing application. But in order to create all this data into this catalog DB, internally Amazon will have their own systems. Okay, their own systems. This is a pricing system or pricing service. Okay, they will have some UI to create the products. They will link products and prices. Okay, products plus prices. So they will have this UI support where they will create the products or link the products with the current prices. They will create prices. So that data will get stored in their pricing deal. In the same way, offer service and offer DB, offers DB. Okay. So this way they'll create different levels of data through different applications. So these two are simple web applications, right? This is one web application. This is one web application. This is having only pricing DB. This is having offer DB. But here I need some relational data. So they will build one more system here. Okay. Which takes the data from both sides, pricing DB, offers DB, do some, combinations, link up the data and put that data into this catalog DB. Okay. So this is one web application, This may be some internal backend application. So together, all these things, all three of these, they collectively create all the information which is needed and putting into this catalog DB. And this front end will refer to this catalog DB. And we know only this front end application. We doesn't know anything about the backend application, backend pricing, offer, and other internal applications what they are using. So this way, we built an enterprise application, right? So Spring Boot gives us the leverage to build these these enterprise applications, like internal web applications or the main enterprise level application, right? With ease, is very easily we can develop the production ready applications because of the lightweight features and the capabilities they added upon top of Spring. I hope you got what I'm trying to explain here in this application, right? Sorry, excuse me. Any questions here, Manjunath?
Yeah, hi Vamshi.
Yeah, any questions here till now? You're good, right?
Yeah, previously, as you mentioned, Spring Boot is a Java framework, right?
Right?
So here my doubt is, it is a one of the part of the, I mean, it is one of the model of the Spring framework, or it is a separate framework. Spring Boot is a separate framework.
Yeah, I'll tell you. So normally, right, at the base of programming language, we have Java. Okay, it's a core.
Yes.
So on top
Yes.
of Java, if we have only Java, we can write some sum of two numbers and some sample logic, okay? But it is not useful for the entire world. We may install or run the executable in our local. So in order to communicate with outside applications, they built up this all HTTP and other stuff, right? So there we
Yes.
have technologies like servlets, JSPs, etc. Servlet, JSP, for example. So this is a technology, and this is a programming language. Okay. So combination of these two things, as I mentioned, we are having some boilerplate code, right? So to remove those boilerplate code and make our development easy, they come up with Spring framework. Spring framework with some low configurations.
Yes. True.
These Spring configurations are mainly XML and annotation. Okay. So like every time we need to make the XML documents change and other stuff and manual configuration, not auto configuration.
Okay.
Right? Again, to add up with microservices functionalities and to remove whatever the bottlenecks we have in Spring Framework, like manual configuration or XML configuration, on top of Spring, they have added additional functionality or additional capabilities that is building Spring Boot. Okay, so here we have an XML configuration. We'll remove that in Spring Boot. We'll use the Java based configuration or annotation based configuration, anything, right? And no need to edit XML documents or anything because we don't have any XML documents there. We'll simply register our beans by using some components. So that we
Mhm.
call as auto configuration. There is no auto configuration in Spring level. Okay. And let's say in Spring, I have built a web application. To deploy that, I need a external Tomcat server. Okay. But in Spring Boot, I have an embedded server. Okay. So if I need to depend on some third party library, again, I need to manually add the dependency here.
Mhm.
But in Spring Boot, we have something called the starter concept, Spring starters.
Mhm.
So where we have a dependency, internally we'll have multiple other dependencies bundled together. So we don't need to worry about the internal dependencies. It will handle automatically in the pom.xml. Okay. Starter is nothing but bundle of multiple jars. So if we select some Spring Boot starter, okay, let's say I need web application capabilities like HTTP, all these things, and I need Tomcat server. Okay. So there I have a Spring Boot starter web. Okay. So if we uh, use this dependency, we will get Spring Web as a dependency. If you know Spring, normal native Spring, you might have observed Spring Web dependency and Tomcat.
Yes. Yes.
Okay. So in web, Spring Boot Starter Web, these two will be available automatically. No need to explicitly add this one separately. Okay.
Okay.
So this solves the starter web solves the issues of version compatibilities because when we say web, so both will be compatible versions will be pulled into our system. Okay.
So here Spring Boot starter is it takes care of to getting the all related, I mean, the
Right.
perspective dependencies from
Right.
the Maven repository. Not only Maven
Exactly.
repository, the organization level also.
Right. So let's say if you have a Spring prior experience, just try when you have some time, create a Spring application and add Spring Web and Tomcat. So in Maven dependencies, you will see them separately. But when I added a web, Spring Boot Starter Web, automatically I'll get two of them. No need to add manually. Okay. So this way starter dependencies solve, version issues and we don't know internally what are the dependencies are to use, but it will automatically pull up all the necessary dependencies. It will take care of the compatibility.
Okay.
right? So this is Spring Boot. So on top of Spring Boot, we using Spring Boot, we will generate microservices or we will develop microservices, small microservices. I'll tell you that. Okay. So Spring Boot gives us the uh, privilege, or we can say some some process to develop all these microservices. But these microservices are also having some issues, some conceptual issues. So that's why to solve them, we have Spring Cloud. I'll explain you that, not an issue. We can say these are microservices one, microservice two, microservice three, microservice four. Let's say we have a big monolithic application, and we break down them into four services. So when we break them into four services, we need a communication, right? We need to have communication between these services. But to have a communication, if I have only one instance of M2, that is okay. But if my load is increasing on M2, I'll simply scale up this. Okay. I'll simply scale up this. Then how can I hard code my IP address? Instance one, instance two. How does M1 know whether I need to go to this service or this service? What if I have 100 instances of M2? How can I hard code 100 IP addresses here? Right? So for that, we need something called some HTTP or IP address management. Okay. And we need some load balancing here. So all these capabilities are provided by Spring Cloud. Okay, I'll tell you. You're clear with this thing, right, Manjnath?
Yes, Vamshi.
Yeah. Just remember
So
one thing, Java.
you see, yeah, yeah. As you mentioned, M1, M2, M3 is a, those are also one of the Spring Boot application, right? M1 also one of
Right,
the Spring Boot application, M2 also one of the Spring Boot application.
right. So those
Okay,
are all small microservices applications built by using Spring Boot.
okay, okay.
Okay. So yeah, Java is a programming language, and on top of that, with the combination using some core features only, they developed something called Servlet JSP as technologies. Without technologies, we can't work with HTTPs and other things, right? Let's say I need to hit one API. That is a technology built by Java, and we are calling that as Servlet, web technology. Okay. And together, Spring Framework is a combination of servlets and Java, for example, technologies and programming languages. So it has removed more of the boilerplate code and other stuff, but still they have some bottlenecks, some issues. So that's why they come up with Spring Boot, and they're rapidly increasing all the features in Spring Boot. They're releasing new versions every time with new capabilities. Recently, I didn't personally went through that, but Spring Boot has added capability for Gen AI as well. So some generative AI concepts in Boot as well, right? So that's why it is expanding very rapidly. It's one of the most important skill that need to be put in resume when people are attending for Java interviews. Without Spring Boot, nowadays I would say 99% no one will hire us, because in the past like 10-15 years ago, people has written applications using Java with Spring Servlets, JSPs, and EJBs, Enterprise Java Beans, right? But nowadays, like not nowadays, like 4 or 5 years ago, people used Spring frameworks, but now all those projects are they are thinking to migrate to Spring Boot for better maintenance and for better deployments and development purpose. So whoever is starting a new application in Java side, definitely they'll use Spring Boot. People who already have applications, definitely they will migrate to Spring Boot. Okay.
Okay, Vamshi.
Yeah. When I say enterprise level applications, I said right, e-commerce, for example, Amazon, Flipkart, etc. Healthcare applications are all also enterprise level applications. So let's say we have J&J, Johnson and Johnson, right? And transporting transport applications, we can say IRCTC, and food delivery applications, Zomato, everything. So any applications which are having all these things, all these uh, you know, front end, back end communication or microservice communication with databases, with messaging tools. So all these things will comes under enterprise level. So Spring Boot would be used over there. Programming language technology framework. So it's a framework for developing enterprise level applications and production ready applications easily. Maintenance also very easy. Scaling also very easy. Reliability is also very easy. Okay. So yeah, now I'll show you. Let's say I'm a customer. So usually customers will interact with us through internet. We don't have any and technical knowledge. We'll simply open our browser or app mobile application. We'll try to access the website or app. That's all, right? So let's say I would like to order a product from any of the e-commerce application. Okay. So I have a database. Okay, basically any application would be divided into three levels. If you know MVC and other concepts, you might have an idea about presentation layer, business layer, and persistence layer or DAO layer. Okay, we'll have three layers here. So take it as presentation layer, business layer, persistence or DAO layer. Okay, so normally, just give me a moment, one sec. Yeah, sorry guys. Okay, presentation layer, business layer, persistence layer, or DAO layer. So we break down our application into three layers. Not only Spring Boot, in Spring as well. Okay. Normally in CoreJava as well, we will segregate them into presentation, business, and persistence or DAO layer. So persistence and DAO layer is something which will directly communicate with our databases. Okay. To separate the logic, in order to uh, decouple the things, we will follow this approach. This is one of the pattern, SDLC pattern. Okay. Because if we club everything together, in future when we have some new requirements, it may be very hectic work for us to edit the code and retest everything. So if we segregate our work or separate our logics from layer to layer, it would be easy to handle. Just it's matter of adding few new functions and few new lines of code. Okay. Yeah. So if I'm using MVC, for example, we'll use models and views, right? This what do we say? Some template engines, right? Some front end views we will use, right? Those will have HTML content, right? So presentation is layer is nothing but if you are using MVC level, some views, or if you are going with boot, nothing but controllers. In Spring also we have something called REST controller, right? Controllers, REST controllers. Okay. So anything which is facing client. So let's say I'm end user in browser. So previously we used to have front end, back end, everything in same application. So I'll get a front end view, obviously. When I say view, the web application. But nowadays I'm an end user. Let's say I'm from other Java application, not from browser. So REST API would be my presentation layer. I'll have REST controller or normal controller with HTTP request. Some slash hello is my API. Okay. So if I'm a Java developer from some other system through internet, I'm reaching your application. Your presentation layer won't be having any front end. I'll just try to access your API. So then I'll become API consumer, you are the API provider. So still we call that as a presentation layer. It just presents something to the user, like API or the front end, application, web application or mobile application, anything, right? For example, as of now, in order to remove the complexity, I'm an end user, I don't have any knowledge. Okay. So let's say I'll get a web application in between. So this will take up the request in the business layer. We'll just concentrate on business logic. Okay. When I say the business logic, the core business logic, let's say I'm ordering service, right? So it will place my order. Okay. It will deduct my payment from the credit card or from my UPI payment services. Okay. Once that is done, from there, it will go to persistence layer where it will update or create an order for me in the database. Okay. So I hope you are clear with this. If you are clear, I'll just add some few other features here. So it will give a complete picture to us. So every e-commerce application need to have an order service, a payment service, right? I'll end up with I'll take only two services here: order service and a payment service. So I'll order something, and I need payment for that. I need to pay the price of the product. Then I'll need to have an entry in the database. Like, okay, this guy has ordered this, and they will deliver for us. Let's say order service, payment. Okay. So from here, it will connect here, it will go here, and it will have an order database, separately order database. I can get rid of this. Payment DB. So it could be anything. RDBMS like MySQL or SQL Server or Oracle or Postgres or IBM DB2, anything. Okay, there is no restriction on the database. Yeah. So when I order something, okay, so I'll click on a product in the presentation layer or in UI. Once I click and try to order that, their business layer will place the order for me. Okay. In between, this may come to payment. Again, the flow will go. Once the payment is done, again it will go back to order and it will place my order DB, my order details into order DB and the payment details into payment DB. And they link up these two database for relationships. Like whoever has ordered that will have a customer ID, right? And that customer ID and pay customer ID will have some orders, and the orders will have some payment details. So both will be linked together using these two databases. Now, if you clearly observe, in every layer we have splitted down the logic like presentation logic, business logic, and persistence logic. Okay. Now, this entire thing is a microservice, order microservice. This entire thing is a payment microservice. This is order microservice. It's a payment microservice, right? Previously in the monolithic applications like 5, 10 years ago, there is no separate order service, there is no payment service. Everything will be clubbed together. For example, I'll have an application. I'm an end user, okay, through internet. So, sorry, end user, I'll simply order something. So there is no order separation service separately, payment service separately. Entire logic will be here. Entire logic will be in a single application. That application we are calling as monolithic. Okay. And database also will have a single database. So for example, assume here, if I have entire thing in a single application, I need to change some logic in pricing code or the payment code. Okay. I need to edit entire project or entire code because even though I'm changing some part, I need to rebuild everything, right? I need to Maven clean install. I need to build the jar again. I need to redeploy entire system. What if I am committing any mistakes and I'm writing the code or changing the code for payment related stuff? By mistakenly order related stuff or code has altered. So that will be an issue for maintenance and deployment, right? But if you consider here, if I need to change order related code, I'll change only order related code specifically. Payment related code won't be touched. It will have the existing code. It won't break the flow. We'll simply change the order related code and we'll deploy only order service. Right? This is a monolithic having lots of maintenance issues and handling issues. This will solve all the problems. Okay. So, okay, that is okay. Order service, order service, order service in all three layers and payment service in all three layers. But they need to communicate here. If you observe, I've drawn some communication line, right? Once we place the order in the business layer, it will redirect us to payment service. Once the payment is done, once the payment is done and money got added into their account, they will check. Or even if you select some COD, they will check that and they will, you know, place our order. Okay, again, it will come back from here to here and it will place the order there. So there is some communication needed between these two services. They are microservices communication. Currently, I have only one order service. Okay, one payment service. So I don't have any issue. Normally, service to service communication is, let's say I have this service, I have another service to service communication using HTTP and the IP address. HTTP, for example, this IP address is 10.0.0.1 and the port number is 8080 slash payments, for example. This IP address is 10.0.0.1 and we have an endpoint called slash payments in our code. And this is 10.0.0.0 IP address. So I'll communicate using HTTP protocol. Okay, HTTP is my protocol. This is my IP address. And in my system where my at which part my application is running at 8080 is the port. Okay, I'll use that. But let's say I am getting I mean huge traffic. If I'm getting multiple requests same time, some thousands of requests or lakhs of requests, my system would not be able to handle this because wherever I deployed this payment service, I have some limited RAM, for example, 4 GB of RAM. Okay. If I have, when I have 4 GB of RAM, let's say I can handle at a time 20 requests, for example, 20 requests per minute. Okay. But I'm receiving 200 requests. I'm getting 200 calls. So then my server will get crash, right? This will get crash. To solve that, they'll go with auto scaling concept. They will spin up this. I mean, they will automatically scale this into other payment service, other instance. Same code I will deploy into one more instance, same payment service. Two. If I have again traffic again, I'll spin up again into three, four, five. So if I have 10.0.0.1 in the as the IP address in the past, what if I have 10.0.0.3 as a IP address here? Port will be 8080 here as well. 8080. Okay. So how I'll be able to communicate? Here I'm hard coding HTTP. Now again I need to hard code that here. I need to say, okay, go to 10.0.0.3 instead of 0.1. What if I have 100 instances of payment services? How I will be able to call them? So we have microservices. This is order microservice, OMS. This is PMS, payment microservice. I built using Spring Boot. These are two microservices. But is it a better solution for us? Building microservices is okay, but how we need to handle them? How we need to uh, manage the load? Okay, we don't know that. I cannot manually take all the IP addresses here in my code, and I cannot hard code every time. So let's say after some time my traffic is reduced and I'll remove this instance. Then how about my code? What should I do? Because I already hard coded two IP addresses inside that. So this is a problem here. Okay. So that problem would be solved by that problem would be solved by Spring Cloud. Okay. So Spring Cloud has given multiple features like, we have something called service registry and discovery client here somewhere. So whoever is having IP addresses, all the IP addresses will get stored in this location. Okay. Some mapping, for example. OMS, payment microservice 10.0.0.1, comma 10.0.0.3. Okay. So in OMS, when I'm calling payment microservice, instead of calling with IP address here, okay, I'll replace this with HTTP colon slash slash or PMS colon 8080 slash payments. So PMS, when I say PMS, it will go to here, it will search, okay, I have two IP addresses. Okay, this way, even though if we have 1,000 instances, 1,000 different IP addresses, we won't have any issue. We call that feature as service registry and discovery client in microservice. Okay, service registry and discovery clients. But you can ask me, sir, okay, I'm having two instances and I'm using the service name here instead of the IP address. But how come it will know to which system or to which instance it need to route every time? What if it goes to 10.0.0.1 and leaving 10.0.0.3 as ideal machine, right? For that, we need to have something called load balancer in between. Okay, load balancer. So this is also one of the feature provided by Spring Cloud. Okay, Spring Cloud provides patterns or capabilities to work with microservices efficiently. Okay, without having Spring Cloud as well, we can generate microservices, but that needs a lot of manual effect like hard coding IP addresses, handling load, right? So that's so here we covered Spring Cloud and microservices and Spring Boot, right? We can say Spring Cloud is also one of the Spring framework. It is written on top of Spring Boot that will give some microservice patterns or capabilities to work with them efficiently. There are many patterns as well. I'll show you. I think I have covered that in syllabus. Yeah, you can see introduction to cloud, load balancing, Eureka server, Zool server, cloud config server, right? So this way it makes our work easy. Got it, right? So in this course, we are going to learn Spring Boot. I mean, the frameworks I'm mentioning here, Spring Boot. So when I say Spring Boot, internally we have Spring Data JPA. Okay. Spring security concepts and the Spring Cloud microservices. And with Kafka as well. At the end of the uh, course, if you have time and when everything goes accordingly, I'll use Kafka as well here. Okay, these many we are going to learn. So my, as I said, prerequisite would be Spring and CoreJava and a little bit of database knowledge. If people are not having Spring framework idea, it may be a bit challenging. I'll try to cover up the basic concepts as well. Okay, but it would be good to have before jumping into the boot directly. Right. So that's all for today. Any questions here, Manjnath, or some other guy joined with the name, some HF? Okay. Any questions?
Yeah, hi, Vamshi. So I have one question.
Yeah,
So
Manjnath.
as you mentioned earlier, so for example, if we get a huge load from any one of the microservices, we can scale out that microservice across the nodes of the cluster, right?
Right, right, right,
So here we have two types of scalings are there. Like one is vertical scaling, horizontal scaling. So it will
right.
microservice. Which one it will support? Vertical scaling or horizontal scaling?
Yeah, it's about horizontal scaling, right? From here you can see. Initially, I have this one service, right? I have this one. Okay. But when the load is increasing, I don't want any downtime. Let's say, take this example, Manjunath. Let's say Amazon. Nowadays, we don't have any festivals. It's a normal regular day, so we don't have any load on Amazon. I mean, the regular load. People will buy products normally. But in October or November or December, when we have the festival season, people will buy like anything, right? Multiple people will come and say, oh, I have an offer, so I need to buy products. So the load will get increased. So assume initially I have one service, this one. Okay. If I go with vertical scaling needs some downtime. Okay. Let's say I have 4 GB RAM in this machine. Vertical scaling will stop this machine, add another 4 GB RAM, and again relaunch. So I'll have a downtime, right? And if users like me and you, if you go to Amazon and see downtime, I'll feel like, okay, this application is having a downtime. I don't need this application. I'll go to Myntra or Flipkart, some other application, right? They don't need the downtime. So that's why they'll go with horizontal scaling. Instead of shutting on the system, they'll create one more instance. Okay,
Okay.
that is horizontal scaling. So
Okay.
this way we don't have any downtime, right?
Yeah. Yeah.
Application would be always keep on up and running. And this ID, once my application is created, instance is created, this IP will go there and register here. So automatically my service would be able to call it.
So that one is the Eureka server, right? As you mentioned.
Yeah, Eureka server. Okay.
So in case as you mentioned, Spring Cloud is the in the Spring Cloud itself, we can mention the like IP address and kind of things, right?
In Spring Cloud, yeah, we need to create a service registry and discovery service. Okay. If we when we create this and mention this is my service, it will automatically register in the Eureka server. From Eureka server, again, we OMS order microservice need to take this name, order service name. We need to create that. That gives the capability, but we need to implement that. Just creating some project and adding few libraries. That's all. Enabling some configuration kind of thing.
And
Cloud
one
gives.
more question, Vamshi. So
Mhm.
what are the design pattern you covered as part of the microservices here and in this
What are
course?
the what are the
Design patterns,
design patterns?
microservices. Yeah.
Yeah. So I'll show you. I've designed my own course as well. 1 second. Let me pull up my document. Yeah. So let's say introduction to microservice, monolithic with microservice, benefits and challenges, communication strategies. Okay. Firstly, service registry and disk registration, API gateway, load balancing. Okay. So service registry, as I mentioned, using the Eureka server, and API gateway I'll use. We have different patterns, Netflix has provided something, and Spring Cloud has other gateways, right? So based
Yes.
on the latest version availability or the best usage in the market, I'll teach that. Okay. And inter-service communication using something called a FAIN client. REST template and web client. REST template is the previous version to call REST APIs, but in Spring 6 or 5.x, this got deprecated and they're using web client now. So if we go with Spring REST template or web client, we need to hard code the IP addresses. But to solve our microservice communication, I mentioned here, this one, we need some capability in the microservice, though that we are calling as FAIN client. Okay. And circuit breaker and resilience. That's all. So these are the main things. Load balancing, service registry discovery client, and one more thing, externalized configuration. So application.yaml, some configuration properties. If I bundle
Yes. Yes.
everything in my jar, let's say after sometimes I need to change one property, again I need to rebuild it. Okay. Instead of rebuilding that, I'll put that configuration outside, somewhere in the cloud or somewhere, S3 bucket or somewhere. Okay, I'll call that as externalized configuration. That is also one of the microservice pattern.
Okay. So
Okay.
can you pull once
And
your syllabus, Vamshi? The
sorry.
screen, sir.
Okay.
Can you pull your syllabus? Yeah. Okay. Comes to security patterns.
Oh, you want to
So
see this one? Okay. Mhm.
so in the syllabus, I think we missed something. So for example, if you want to communicate, manage the transactionality between the one microservice to another microservice, which is we need to go here?
One microservice to other micro. That is inter-service communication using Fain client.
Yeah, I mean to managing the transactionality between two microservices.
To manage the transactions.
Yeah,
When I say the
transaction.
transaction, I mean, uh, I didn't get your question exactly. If you say transaction,
For
let's say I'll hit an
example,
API. Uh-huh.
okay, I will clear that one. For example, we have a M1 is a one microservices, M2 is a one microservices.
Mm-hmm.
For each microservice, we have a separate databases.
Right.
So while inter-service communication, one microservice depending on other microservices. So in this
Right.
case, we need to manage the transactional between the one microservice to another microservices, right?
Right.
For example, in one of the microservices failed based on some
Mm-hmm.
issues. So in
Mm-hmm.
this case, we need to run back the data from the both the services,
Right.
microservice one and microservice two.
Right. Right.
So managing this transactionality, which design pattern we need to go here? I think you are
Yeah.
not mentioned one.
Yeah. There might be any pattern, but the way we handle it is through the code. Let's say when we hit an API, we will get a response, right? Let's
Yes.
say I'm hitting an API from for other microservice, and I'm not authorized to access that resource. For example, I'll get 400 response or 401 authorized or 403 forbidden. Okay, based on that error response, let's say some internal server error at 500 side, I can handle here. So no need to go to any specific pattern there in the transaction management side. Though if we have any pattern, we can use that. But normally, based on the API response, we'll take the call, not on the communication, right? Let's say if I hit somewhere, it will give a response back to me saying, hey, your API is success or failure or unauthorized or unauthenticated or forbidden or internal server error. Based on that, I'll say, okay, complete the transaction or roll back the transaction there. Because I'll use Spring Data JPA here. If I'm dealing with databases, automatically transaction management would be handled in the data JPA side. Okay. So if there
And
is
then,
an,
see, so whenever we use the Spring Data JPA, so each makes one database. I mean, one Spring Boot application, right?
sorry, each,
Microservices is a one Spring Boot application.
right.
So whenever we use the Spring Data JPA, but to the boot application will be handled the exception. My question here is, for example, microservice depending on other microservices because one
Mhm.
microservice input as a sorry, one microservice input output as another microservice input. So in this
Right.
case, how to handle the transactionality?
Okay. There is something called, Saja patterns, right?
Yeah,
Have you heard about Saga or Saja patterns?
yeah, Saga.
Okay. Those things in Spring Cloud, whether they are providing or not, I'm not sure because I worked in something, some other way. Okay. There should be a pattern. As you said, there should be a pattern. But
Okay.
automatically, when we say output of one thing would be input of other thing, but we'll hold up the code there, right? If I'm making a REST call there, my
Yeah,
code
yeah.
will hold up there. Based on the response, I'll follow the next steps. If it is a synchronous thing, right? We
Okay.
have asynchronous calls as well. When we have asynchronous calls, so then we may need to go with the pattern. When I say
Yeah.
asynchronous, for example, let me pull up the pane.
Yeah, sure.
1 second. So I have this, I have this. So I'm having some lines of code here. Let's say here I'm making API call. So normally when we have a synchronous calls, we will wait for the response. Okay.
Yes.
Once I get a response, then only based on the response type, I'll execute the next steps. If some API error, I'll stop the transaction, some kind of thing. But when
Yes.
there we don't need any pattern here. But when it comes
Yes.
to asynchronous calls, as you said, then okay, I'll hit it, but I'll execute next lines and I'll make another API simultaneously. There
Yeah,
we
yeah.
might need to put that pattern to what do we say? Handle the transaction management. Okay, so we have some patterns. I work with something called Saja or Saga pattern. I don't know how people would pronounce it, but yeah,
Saga pattern. That is Saga pattern.
Saga. Okay, right? Yeah, I'll include that one as well in the curriculum. Okay, So basically, this is
Yes.
my own curriculum, not provided with the DurgaSoft people. But if you see, this
Okay.
is the
Okay.
syllabus from DurgaSoft. I'll share this link.
Okay. Sure.
Okay, one of the other faculty member, you can see. Normally, they are covering microservices. Okay, config server, externalized config server, load balancing, Eureka, Zool. Only these four patterns. Okay.
Hmm.
So we are adding something called API gateway. Okay, Zool is an API gateway. Okay, yeah. Based on the flow, at the time we will be when we reach that level, so we'll build microservice, right? So there we can handle that much, not an issue. Okay, I'll add up that.
Yes. Sure.
Okay,
Okay.
yeah. Glad you asked that question. Okay, and yeah. Any other questions? I don't know.
Uh,
There
no,
is
Vamshi.
someone called HF. I don't know what's their name. Yeah. So tomorrow also we'll be having one more demo. So tomorrow I'll just walk you through the syllabus and say what are the Today I just give you some conceptual idea, right? What we are doing, what exactly happening, that thing. I'll see
Yes.
what
Yes.
internally we have. I'll try to cover up for 1 more hour. From next week, we'll start the live classes. Okay.
Okay, Vamshi.
So yeah, feel free to join tomorrow as well, and let me know if you have any questions.
No, Vamshi. I don't have any question.
Right. So yeah, that's all for today, guys.
Thank you.